Welcome to the exciting world of electronics. You're about to meet two of the most useful integrated circuits ever made. These are the 555 timer and the operational amplifier, or op-amp. Think of them as tiny electronic brains. You can use them to build hundreds of different circuits. The 555 timer is like a very reliable clock. It is excellent at creating pulses and delays. The op-amp is different. It is like a powerful magnifying glass for electrical signals. It can make very small voltages much bigger. Both are essential parts for any electronics hobbyist to know and understand. These two chips look very similar from the outside. They are often sold in a black plastic package. This package is called a dual inline package, or DIP. It has 8 small metal legs, or pins. 4 pins are on one side and 4 are on the other. But inside these black boxes, the circuits are very different. The 555 timer was made specifically for timing tasks. The op-amp was made for amplifying signals. Even though they look the same, their jobs are not. Learning about both of them will open up a huge number of project possibilities for you to explore. For a beginner, the 555 timer is often the friendlier starting point. Its purpose is very clear and easy to grasp. You can make lights flash or buzzers sound with just a few extra parts. You do not need to understand a lot of complex math to make it work. The op-amp, while incredibly versatile, can sometimes be more confusing at first. It deals with concepts like gain, feedback, and input impedance. These ideas can be a little abstract when you are just starting out. The 555 lets you see and hear your circuit working right away, which is very rewarding. So, we have two powerful tools. One is a master of time, the 555. The other is a master of amplification, the op-amp. Both are low in cost and easy to find at any electronics store. They are like the basic alphabet of the electronics language. Once you learn how to use them, you can start to form electronic words and sentences by combining them into circuits. In this guide, we will look at how they work. We will also see which one might be the best for you to start with on your journey into electronics. Let's begin exploring these amazing little chips. The 555 timer has a very specific job. Its main purpose is to create a timed electrical signal. It can work in a few different ways. One way is called a stable mode. In this mode, the 555 creates a steady stream of on and off pulses. This is perfect for making an LED blink or a speaker click over and over. Another mode is monostable. In this mode, the 555 creates a single pulse of a specific length when you press a button. This is useful for making a timer that turns something on for just a few seconds. The timing is controlled by two simple parts, a resistor and a capacitor. An operational amplifier, or op-amp, has a different primary function. Its main job is to amplify or increase a voltage. It has two inputs, called the inverting input and the non-inverting input. It also has one output. The op-amp looks at the difference in voltage between its two inputs. Then it multiplies that difference by a very large number. This new, much larger voltage appears at the output. For example, a tiny signal from a microphone can be made strong enough to drive a speaker. This ability to amplify makes the op-amp a key part of many audio and sensor circuits. How do you tell these chips what to do? For the 555 timer, its behavior is set by how you connect external resistors and capacitors to its pins. By choosing different values for these parts, you can change how long the pulses are or how fast they repeat. It's kind of like setting the hands on a clock. The op-amp is also controlled by external parts, mainly resistors. By connecting resistors between the output and the inputs, you create something called a feedback loop. This feedback is what tames the op-amp's huge amplification power and lets you control it precisely for your specific needs. So let's review. The 555 timer is a specialist. It is designed to be an electronic timer or oscillator. Think of it as a wind-up toy that runs for a set time or a metronome that clicks at a steady beat. The op-amp is more of a general-purpose tool. It is a high-power amplifier that can be adapted for many tasks. It can be used to compare voltages, add or subtract signals, and even act as a filter. Both are controlled by simple common components that you will find in any beginner's electronics kit, making them easy to experiment with. When you decide to build a circuit, you will need some parts. Let's look at what you need for a basic 555 timer project. To make a simple flashing light, you will need one 555 timer IC. You will also need two resistors, one capacitor, and one LED. Of course, you will also need a power source, like a 9-volt battery, and a breadboard to connect everything without soldering. These parts are very common and very cheap. You can find them in almost any electronics hobby shop or online store. Putting them together on a breadboard is simple and follows a clear diagram. Now let's consider the parts for a basic op-amp circuit. A simple amplifier circuit using a 741 op-amp will also need the op-amp IC itself. You will need at least 2 resistors to set the amplification level, or gain. Just like the 555, you will need a power source and a breadboard. One important difference is that many common op-amps, like the 741, need a dual power supply. This means they need a positive voltage, a negative voltage, and a ground connection. This can be more complicated for a beginner than the single power supply needed for the 555 timer. The ease of building is a very important factor for a beginner. The 555 timer circuit is usually easier to build correctly on the first try. The connections are straightforward. The result is easy to see or hear. If your LED blinks, you know it is working. Troubleshooting is also simpler. If it does not work, the problem is usually a misplaced wire or a component in the wrong spot. The immediate feedback of a working blinker or buzzer is very encouraging and helps build confidence. This makes the 555 a great first step in practical circuit building. Building an op-amp circuit can be a little more challenging. The concept of a dual power supply can be confusing. It is also very easy to connect the op-amp in a way that causes it to not work as expected. The output might be stuck at the maximum or minimum voltage. Without an oscilloscope to see the signals, it can be hard to know if your amplifier is working or what it is doing. This is why the 555 is often recommended as the first integrated circuit for a student to work with. It provides a more gentle and rewarding introduction to the world of ICs. When you build a circuit, you are also learning. The 555 timer is a fantastic teacher for some fundamental concepts. As you build a 555 a stable circuit, you will learn directly about resistors and capacitors. You will see how changing their values changes the flashing speed of an LED. This gives you a hands-on understanding of RC time constants, which is a core idea in electronics. You learn about how components work together to create a function. You also learn about the pins of an integrated circuit: power, ground, output, and control pins. It is a very practical lesson. The op-amp, on the other hand, is a gateway to learning about analog circuit theory. Building an op-amp circuit teaches you about concepts like voltage gain, feedback, and input impedance. You learn how a tiny, weak signal can be made strong and useful. You will discover the difference between an inverting and a non-inverting amplifier. These are more abstract ideas than the 555 simple timing. Learning with an op-amp builds a deeper theoretical foundation. It prepares you for more advanced topics like signal processing, audio electronics, and designing sensor interfaces. So, which circuit helps you learn more? It depends on your goal. If you want to learn the practical basics of how components create a visible and audible result, start with the 555 timer. It teaches you the cause and effect relationship between parts and circuit behavior in a very tangible way. If you are more interested in the theory behind how signals are manipulated and amplified, the op-amp is a better choice. It is a step closer to how real-world analog systems are designed. Both paths are valuable, but the 555 provides a gentler learning curve for the absolute beginner. My advice for a student choosing between them is simple. Start with the 555 timer. Buy a kit or find a simple project online to make a flashing LED or a simple siren. The success you will have with this first project will build your confidence. You will learn important skills like reading a circuit diagram and using a breadboard. Once you are comfortable with the 555, then move on to the op-amp. The lessons you learned from the 555 will make the challenges of the op-amp much easier to overcome. This step-by-step approach is the surest way to a fun and successful journey in electronics.